Thank you, Rudy, Luke. I want to give a slightly different perspective. You've heard all day long on advanced technologies, product development, the ecosystem, but what does it really take to take all of these advanced technologies and product development into real in the hands of the customers, right? So there are a few things that we see, and the talk is kind of, the outline of the talk is to talk about some of the challenges and opportunities in semiconductor growth. And it's three sections. One is we'll focus on the foundry economics to give you some perspective on what it takes to build an advanced fab and things like that. And more, which is basically the advanced technology, where are the challenges and the risks, and then more than more. I'll try to go as fast as I can, and we'll see how much I can cover. First of all, a very quick introduction of GlobalFoundries itself. We really started in 2009 as a spin-off of the AMD manufacturing unit with a very advanced fab in Dresden. And that was the inception time. And in 2010, we acquired Chartered Semiconductor to get all of the foundry engine. So we went from one customer, which was AMD, in 2009 to about 160 customers after integration with Chartered. The next year was all about transformation. We had a complete leadership change. We had a new CEO. We had a new strategic initiatives put in place. And then we have achieved a lot since then. So we went from number 4 to 3 to 2. So we are number 2 foundry today, and we definitely want to be number 1. So let's talk about the foundry economics. We all know this transistor scaling gives you better performance cost. You heard all of that all day, which feeds into the market growth, which further feeds into the new investments in advanced technologies and manufacturing and so on and so forth, and that's the cycle. And we have also seen this. There's a lot of great predictions about how the mobile market is growing, in turn driving the semiconductor growth. And mobile, of course, is at the heart of all of that. There's huge silicon consumption predicted, but let's take a look at it and see where the challenges are. First of all, when you talk about the overall semiconductor growth, foundries, the advanced manufacturing, is really very critical. And if you look at the semiconductor industry growth, there's a prediction of about 5% growth annually. But the foundry is growing at twice that rate. Okay, you've got to see why that's happening. And then if you zoom in a little bit more into the advanced technology is growing at a much, much higher rate, almost 7 times that of the semiconductor industry itself. There are a few reasons why this is really happening, but let's look at one of the dynamics here. Typically what happens is in an advanced manufacturing, at time 0 that you see on the left side, the computing industry is typically the leading adopter of advanced technology, high premium products. They take over, build the wafers, and the equipments get depreciated, bring down the wafer cost, and then typically the wireless follows and take full advantage of all the depreciated wafer cost. And then comes the consumer products, typically the mature technologies, and that's how the cycle has been for a while. And that also helps in the capacity utilization. As you see, the curves are very well aligned there. But what is evolving is a little bit interesting. You kind of saw that in some of the talks earlier today. The mobile computing is getting into advanced technology. It conflicts and competes with the computing capacity, and you saw some of the recent capacity shortages in the world and all of that. So that is definitely a challenge, right? And we need to really take care of that and need to keep that in mind. If the mobile computing is going to consume more and more advanced technology silicon, this problem will continue. And also the advanced technology is becoming really complex. It's more expensive. Gary talked about it, Luke talked about it, Rudy talked about it earlier as well. Everything is getting really complex, and one of them is the litho. The optical, the number of double patterns and triple patterns is really increasing on the advanced technology. So if the computing industry is using advanced technology and the huge growth, which is the mobile computing, is starting to use the advanced technology, but the advanced technology is getting complex and expensive, there is a bit of challenge. So if you want to take all this into high volume production, end of the day, it costs a lot of money. So if you look at what it takes to build a new advanced fab, okay, on every new node, the cost of building a new fab is going up significantly, almost 40% on each node. And that's huge, okay? And then if you look at where exactly is the huge cost, it's really the equipments, right? On every technology node, the cost of equipment is very complex and therefore it's very expensive. And when we go beyond optical to EUV, actually the EUV, it's really very expensive, as you all know. And it takes 5 Boeing airplanes to ship one single EUV unit. And everybody talks about EUV as a savior. It really, you have to really check it out, because there's huge investment that goes in, and then you have to, there's an ROI based on that. All that will be transferred to the wafer cost. So when mobile computing is being quoted as being one of the fastest growing segments, please note some of these problems have to be first solved. So within the equipment, there are litho is definitely the most expensive one, and I just talked about that. However, we always try to work our best to bring down the wafer cost, and this is the general trend in the foundry, and there are many reasons and many ways to do that, and we continue to do that. However, the starting wafer cost at the beginning of the advanced technology is really high, and it's getting just higher and higher, as I just explained. What this really means is, when you put in investment in an advanced technology manufacturing unit, right, at time zero, when you start to sink the money, the solid line that you see, it takes a while. The gestation is pretty long before you start to see any returns on it until you ship your first wafer for revenue. And then it takes a while to get cash flow positive, and then of course you start to get your money. But so you really need patient capital. You need to be able to take that risk. And then beyond that, of course, the mature technology will, the wafer ASPs will start to come down. And there's a long life, almost about 10 years roughly for any technology node. But you need to see the return on investment on that. The dotted line that you see is the more advanced technologies, the future technologies, which involves even more investment, which means the return on investment is even longer. What this has led to in the industry is, as you see, about 10 years back, there were more than 20 companies who could afford to do advanced technology manufacturing. We are specifically quoting, the large high volume manufacturing, no offense to anybody. This is more than 600,000 wafers per year. If you look at that, and not memory included, just logic, there were more than 20 companies 10 years back. There are only 4 now. Simply because of all the foundry economics that I just talked about. This is not an easy task. This is a huge challenge. You really need patient capital. It's a long gestation, and please note that it runs into several billions of dollars to build a new fab, and I'm going to talk about that in just a second. Looking at it from another angle, okay, there are 3 real critical aspects, and you did hear some pieces of it today. One is, of course, the fab cost that I just talked about. There's also the process development cost. Every technology node, developing a new technology is not easy. Gary talked about all the challenges this morning. Luke talked about it. And it's very, very complex. You need global talent. You need a lot of money in experimenting and checking out few things before you can conclude the right approach. So that's where the collaborative R&D comes into play. Today, the cost of developing a new technology is way beyond $1 billion. And then, of course, the chip design cost. It's very complex. The chip design cost is going up. So if you really put this in perspective, everything is going up, but however, we need everything for less than $100 end of the day. So there is a big disconnect there. What we have done as Global Foundries is we've looked at all of these challenges. We are looking at very strategic initiatives next 5, 7, and 10 years. And we have changed the foundry model. The traditional model was, geographically centralized or localized, in an island or in some place. Make use of the local talent there, try to see what you can do. It's not just possible going forward. So I'll jump to the final, the last block that you see there, which is the collaborative device manufacturing. That's exactly what we are doing. We are working with customers very, very closely. We are tapping into the global talent, and we are trying to mitigate geographic risk as well. That's the whole idea of collaborative device manufacturing, because you got to partner with your technology R&D ecosystem and with customers.